Floating in Subic Bay, this vertical skyscraper ship redefines structural mechanics, masking a catastrophic hull vulnerability. By stacking residential blocks atop dynamic foundations, engineers unknowingly created a fatal, complex hydrostatic crisis. Entering dangerous open ocean corridors, its massive surface encounters severe wind shear, multiplying sudden capsizing risks. Fabricating this structural behemoth demands extreme precision, where every automated weld bears immense deep-sea strain. Inside futuristic offshore assembly yards, high-strength steel plates are precision-cut using advanced thermal plasma systems. To fuse these monumental bulkheads, specialized industrial operators manage heavy-duty machinery along critical stress lines. Under intense deep-sea kinetic loads, a single manufacturing deviation propagates a sudden, uncontrollable structural tear. Out in violent open seas, daring technician teams risk everything, anchoring critical joints on metal frameworks. Every localized overloading force threatens to push this delicate single-pier equilibrium past its tipping point. Inside lower machinery decks, a grid of high-pressure hydraulic lines operates near absolute physical limits. Advanced maritime sensors are calibrated to track real-time hull stress variations against aggressive underwater currents. Engineers initiate secondary ballast flooding tests, micro-adjusting pressure differentials under fierce storm wind simulations. Completing this vertical monolithic superstructure requires absolute balance, avoiding irreversible systemic tilt on rough seas. Massive high-pressure hydraulic actuators assemble the upper residential multi-tiered framework with extreme millimeter precision. Outside the hull, specialized industrial operators deploy heavy anti-corrosion polymer coatings amid raging dangerous waves. A single localized manufacturing miscalculation exposes this entire floating skyscraper to sudden and catastrophic collapse. Deep inside machinery spaces, the twin-stroke diesel propulsion unit undergoes maximum torque stress safety tests. If structural joints flex beyond safety limits, severe ocean wind shear immediately multiplies dangerous capsizing vectors. Industrial technicians race against incoming typhoons to secure vital heavy anchoring lines to deep-sea beds. On the open sea, terrified residents feel the massive 20-story framework violently shuddering against waves. The hyper-modern digital observation decks tilt aggressively as water impacts the lower stabilizing compartments. Extreme hydrostatic load concentration strips the single-pier equilibrium, triggering a progressive, uncontrollable kinetic failure. When minor manufacturing errors accumulate under pressure, this architectural triumph transforms into a death trap. High-strength structural bulkheads split open, allowing surging ocean water to compromise inner airtight bulkhead lines. The majestic towering ship loses total buoyancy control, sinking hopelessly into a massive, destructive whirlpool. Heavy-duty industrial gantry cranes align the multi-ton bronze propeller shaft along the lower central axis. Multi-axis robotic units execute automated ultrasonic welding scans on critical high-stress structural engine plates. Constructing this massive 20-story vertical maritime structure requires flawless distribution of complex dynamic ballast networks. Inside the main control deck, engineers install computerized microgrids to monitor severe open ocean wave impacts. Outside the hull, specialized industrial technicians secure heavy high-pressure stabilizing fins against aggressive ocean swells. Under intense kinetic forces, a microscopic alignment failure instantly destabilizes the entire vertical skyscraper ship. Daring offshore technicians balance on high-altitude steel scaffolding to finalize upper multi-tiered communication arrays. When localized stress loads exceed critical thresholds, this massive engineering triumph becomes an immediate fatal hazard. Deep inside machinery spaces, high-pressure fluid valves undergo extreme stress tests under simulated typhoon conditions. Terrified citizens clustered on upper residential balconies watch giant dark green waves swelling violently below. The modern futuristic concourses tilt aggressively, fighting the relentless kinetic weight of a massive whirlpool. High-strength internal steel bulkheads rupture under immense hydrostatic tension, losing total dynamic buoyancy control. Accumulated manufacturing inaccuracies turn this advanced floating skyscraper into a catastrophic death trap mid-ocean. Surging ocean currents violently tear through inner airtight compartments, fully exposing critical structural vulnerabilities. The majestic tower ship collapses into the deep ocean vortex, leaving zero trace against the horizon. Automated magnetic cranes position thick, high-strength steel bulkheads onto the upper superstructure deck lines. Multi-axis robotic lasers execute synchronized continuous welds along the lower, watertight compartment seams perfectly. Assembling this monumental 2-story vertical maritime structure redefines the absolute boundaries of architectural balance. Heavy-duty offshore transport modules move massive computer-guided stabilizing fin structures toward the main dock. Daring industrial technicians wearing matching neon green suits secure high-pressure hydraulic actuators under fierce winds. Under immense deep-sea dynamic tension, a minute geometric deviation instantly triggers structural stress fracturing. Inside the lower propulsion bay, engineers execute maximum torque simulation tests on twin-stroke gears. If localized load limits exceed safety thresholds, this advanced engineering triumph becomes an immediate hazard. Offshore operators sprint across vibrating metal platforms to secure heavy, high-tension deep-sea anchoring lines. On the open sea, terrified citizens look down from multi-tiered balconies at massive churning whirlpools. The hyper-modern digital observation decks tilt violently under the relentless kinetic impact of rogue waves. Severe hydrostatic overload strips the single-pier equilibrium, initiating an uncontrollable progressive mechanical collapse. Accumulated manufacturing inaccuracies transform this futuristic floating skyscraper into a catastrophic death trap mid-ocean. Surging dark emerald ocean currents tear through inner airtight bulkhead lines, exposing critical vulnerabilities. The majestic vertical tower ship completely loses buoyancy control, sinking hopelessly into the deep ocean vortex. Colossal automated conveyor belts shift high-pressure centrifugal desalination units into the mid-level utility bays. Multi-axis robotic arms perform laser alignment on heavy structural damper joints beneath the lower hull.
We are live at the Nexus Prime shipyard, where the first interstellar vessel is preparing for launch, representing a monumental leap for humanity.
Inside the central engineering hub, technicians install digital microgrids to track severe open ocean vibrations. Outside the hull, specialized industrial teams secure high-pressure hydraulic stabilizing fins against aggressive sea currents. Under intense hydrostatic load, a microscopic alignment failure instantly triggers a sudden, catastrophic structural tear. Daring offshore technicians balance on high-altitude steel frameworks to finalize the upper sensor arrays. When localized stress loads exceed critical safety limits, this advanced engineering triumph becomes an immediate hazard. Deep inside machinery spaces, high-pressure fluid valves undergo extreme power tests under simulated typhoon conditions. Terrified residents living on the upper residential tiers look down at the churning dark emerald waves. The modern futuristic concourses tilt aggressively, failing to resist the relentless weight of a whirlpool. High-strength internal steel bulkheads rupture under intense tension, completely losing total dynamic buoyancy control. Accumulated minute manufacturing inaccuracies transform this advanced floating skyscraper into a permanent deadly ocean trap. Surging ocean currents violently tear through inner airtight compartments, fully exposing hidden dynamic design vulnerabilities. The majestic towering ship completely collapses into the deep sea vortex, leaving zero trace against horizon. Heavy-duty electromagnetic cranes lower massive bridge navigation modules onto the ship's highest forward structural points. Multi-axis robotic lasers execute automated precision cuts on high-strength titanium window frames for observation. Constructing this massive 20-story vertical skyscraper ship requires absolute precision in alignment to prevent tipping. Inside upper command structures, technical crews install high-speed fiber optic data networks to monitor hydrostatic changes. Outside the superstructure, industrial painters apply advanced reflective thermal polymer skins amid violent sea spray. Under intense kinetic wind loads, a single microscopic joint flaw can initiate total structural failure. Deep inside the hull, specialized operators test high-volume automatic ballast pumps against sudden water displacement.
Parts in place här. Han är så för det främsta kjolstingsby. Say.
Daring offshore technicians sprint across wave-lashed scaffolding to anchor heavy radar arrays before storms. Terrified citizens trapped on open residential decks look down into a swirling, violent oceanic abyss. The futuristic internal concourses tilt severely as massive wave walls slam against reinforced lower hulls. Extreme hydrostatic stress concentration completely cracks the watertight bulkheads, forcing rapid and uncontrollable flooding. Accumulated minute engineering oversights quickly transform this advanced floating masterpiece into an immediate deadly trap. Raging dark emerald currents violently puncture through secondary airtight compartments, tearing apart the inner framework. The colossal vertical tower ship loses total buoyancy, diving directly into a massive, destructive ocean whirlpool. Colossal automated winches roll heavy-duty electrical cables into the ship's lower distribution grid lines. Multi-axis robotic units execute automated microscopic alignment on high-load roller-bearing plates beneath modules. Constructing this massive 20-story vertical skyscraper ship requires flawless synchronization of complex electrical routing networks. Inside the primary power substation, engineers deploy computerized safety breakers to handle severe ocean spikes. Outside the hull, specialized industrial teams anchor high-pressure cooling water lines against aggressive oceanic currents. Under intense kinetic load distributions, a single insulation failure instantly compromises the entire vertical structure. Daring offshore technicians balance on high-altitude steel scaffolding to finalize secondary emergency illumination matrices. When localized electrical loads exceed critical thresholds, this advanced engineering triumph becomes an immediate hazard. Deep inside machinery zones, high-voltage transformer units undergo extreme capacity tests under simulated hurricane conditions. Terrified citizens clustered on upper observation platforms watch giant dark emerald waves swelling violently below. The modern futuristic interiors tilt aggressively, failing to resist the relentless dynamic weight of whirlpools. High-strength internal power trunkings rupture under intense structural flex, losing total automated control system operations. Accumulated minute manufacturing inaccuracies quickly transform this advanced floating masterpiece into an immediate deadly trap. Surging ocean currents violently tear through lower circuit compartments, completely exposing hidden grid design vulnerabilities. The majestic vertical tower ship completely collapses into the deep-sea vortex, leaving zero trace against horizon. Heavy-duty automated cranes lower the massive multi-ton hydraulic steering rudder system into the aft bay. Multi-axis robotic arms perform precision laser alignment on high-torque steering gear mount plates under pressure. Constructing this massive 20-story vertical skyscraper ship requires absolute precision in dynamic steering alignment stabilization. Inside the lower steering compartment, engineers deploy computerized hydraulic microgrids to monitor severe marine impacts. Outside the hull, specialized industrial teams anchor high-pressure actuator lines against aggressive open ocean currents. Under intense dynamic steering stress, a microscopic geometric deviation instantly triggers sudden structural fracturing. Daring offshore technicians balance on high-altitude steel frameworks to finalize upper automated navigation sensors. When localized steering loads exceed critical safety limits, this advanced engineering triumph becomes an immediate hazard. Deep inside machinery zones, high-pressure hydraulic fluid valves undergo extreme capacity tests under simulated storms. Terrified residents living on upper residential tiers look down at the churning dark emerald waves. The modern futuristic concourses tilt aggressively, failing to resist the relentless weight of a whirlpool. High-strength internal steel bulkheads rupture under intense hydrodynamic tension, completely losing total dynamic buoyancy control.
Fabricating film like this, and when temperature är belägger sprint snart då en projekt där issinga the tennis away.
Surging ocean currents violently tear through inner airtight compartments, fully exposing hidden dynamic design vulnerabilities. The majestic towering ship completely collapses into the deep-sea vortex, leaving zero trace against horizon. Automated industrial winches position heavy high-capacity stabilizer fins along the ship's lower structural keel lines. Multi-axis robotic arms execute precise mechanical torque calibrations on critical automated steering servo mountings.
From the highly coordinated construction efforts to the sheer scale of the operation, this shipyard represents a new era of engineering.
Inside the central control hub, engineers install dynamic microcircuitry to monitor sudden deep-sea tidal impacts. Outside the hull, specialized industrial technicians lock high-pressure auxiliary fluid valves against violent marine currents. Under intense kinetic stress loads, a minute manufacturing error instantly compromises internal bulkhead equilibrium. Daring offshore operators balance on slick, high-altitude scaffolding to secure the upper computerized navigation array. When localized structural tension exceeds critical limits, this advanced engineering triumph becomes an immediate trap. Deep inside machinery spaces, high-pressure hydraulic actuators undergo extreme endurance testing under simulated storm winds. Terrified citizens clustered on multi-tiered upper balconies watch monstrous dark emerald waves swelling violently below. The modern futuristic concourses tilt aggressively, completely failing to resist the crushing weight of whirlpools. High-strength internal steel walls rupture under immense hydrostatic pressure, triggering a massive kinetic structural failure. Accumulated minute design discrepancies turn this advanced floating masterpiece into a catastrophic floating tomb mid-ocean. Surging ocean currents violently tear through inner airtight compartments, fully exposing critical dynamic vulnerabilities. The majestic vertical tower ship completely loses all buoyancy control, sinking hopelessly into the deep vortex. Automated pressure valves inside lower subcompartments fail completely under severe and sudden hydrokinetic stress. Multi-axis robotic stabilizers fail to counteract the extreme tilting moment induced by localized structural warping. The massive 20-story vertical skyscraper ship suffers immediate double-hull breaches from crushing deep-sea ocean currents. Inside primary machinery zones, computerized high-pressure hydraulic grids rupture under intense mechanical load displacement. Outside the compromised superstructure, specialized technical operators are evacuated past vibrating industrial dock lines. Bound by immutable laws, minor manufacturing discrepancy strips the vessel of its remaining dynamic equilibrium. Terrified residents look out from the tilting futuristic concourses as dark emerald wave walls expand. The magnificent towering masterpiece splits along critical weld paths, breaking under extreme physical tension lines. The monolithic structure completely collapses into the destructive whirlpool, erasing this floating hazard from existence. This documentary is for education only, based on real sources. Theories are not facts.